Okay, in this video we're gonna continue we'll work with Pythagoras. We looked at finding the length of the hypotenuse and finding lengths of the smaller sides using Pythagoras in the last two videos. Now we're going to look at some problems where you use Pythagoras. So this is applications of Pythagoras. So in this one all we're going to do is use what we've learned in the last two videos to figure out how to solve different types of problems. So the first problem, I haven't written it down, so I'll just read out what it says. A ladder 12 meters long leans against a wall. The ladder reaches 10 meters up the wall. How far away from the foot of the wall is the foot of the ladder? So we've got a ladder 12 meters. This here can be your ladder with 12 meters, and then we've got a wall here which is 10 meters. We want to find this distance here. Because it's Pythagoras, we're going to have a right angle triangle there. So what we need to do is because we'll find the smaller side, we'll do the biggest length squared minus the smaller one. So we'll get the square root of 44, which we can figure out on our calculator however many decimal places we want, or if the question wants you to leave in third form, you can simplify this as a third. So that's all we really have to do for that one. Next one, we've got a triangle here and we want to find the area, but remember the area of a triangle is 1/2 times base times height, and the height is this here, so we need to find this length here, and then we can find the area. Because this is isosceles, what we can do is we can break it up into two using the dotted line as I've drawn on the diagram there. So now we've got a right angled triangle. Now be careful, with half this line, so this bit becomes 4 centimeters, and this bit here has 9. And we're going to do 9 squared minus 4 squared, so that's 81 minus 16, which is 65. So then we'll get the square root of 65, and that's this length here. So this length here is square root of 65, whatever that turns out to be. So then what you do is you just put it in your formula. So we'll get 1/2 times the base here is going to be 8, because that's the whole of the base. I've just split that up so that we could apply Pythagoras, because we also need this length here, and then you times that by square root of 65. I'm not going to do the calculation because the numbers aren't very good, but if you round that to the nearest number, you'll basically just get 1/2 of 8 times 8, so we'll get 32 centimetres squared. If you want it to the nearest centimetre, that's what you would get. Okay, next problem, we've got 2 points here, and we know that the first ones were x coordinate, second ones were y coordinate. So let's just draw a diagram. This is our y axis, this is our x axis. I've got a point 1, 1, and then I've got another point here, 13, 6. This here is point B. And then we've got point A, which is 13, 6. So this is what x coordinate along here. So we'll go along 13 and then up 6. So this here will be your point A. And to apply Pythagoras, we need to find this length and this length. Notice this length here has the difference in the x coordinates, so that would just be 13 minus 1, so that's 12. And this length here is just the difference in the y coordinates, that's 6 minus 1, so that's 5. And then we can apply Pythagoras on these two sides to find this side, which is AB. So then do 5 squared plus 12 squared, which is 25, plus 144, which is 169, square root that, we get 13. So the length of this line here, AB, is 13. That's the solution for that problem. So you take the difference in the x coordinates and the difference in the y coordinates, and then you apply Pythagoras as you would for a normal right-angled triangle, as I've just showed you in the diagram there. Next problem is pretty challenging. We've got a square. Let's just draw this so you can see what's going on in the problem. And let's see what we're told. We're told that the length of the diagonal is 20 centimetres. So this here is 20 centimetres. And we'll have to find the length of a side of the square. Now, the thing to recognise here is that the formula for Pythagoras is this. But we know that in a square, these two sides are the same. So then we'll get this. Then we can just write it as a squared plus a squared c squared, which by collecting the like terms, you would get that. Then we know that 2a squared is equal to 400 because you square 20. And then we're basically just solving this equation. So then we know that a squared is 200 just by dividing both sides by 2 here. And then you just square root both sides. So you get a is the square root of 200, which the two decimal places would be 14.14 centimetres. So each length of this square here would be 14.14 centimetres. Okay, so that's just how we use Pythagoras to solve a few different types of problems, just to help you with problem solving.